Welcome to this explainer on digital forensics and evidence analysis. If you work in corporate investigations, cybersecurity, or compliance, you rely on digital logs every single day to reconstruct reality. But today, we're examining a critical vulnerability in that process. The reality is your investigation can be completely technically correct, yet chronologically entirely wrong. Think about this for a second. If one system records an event at 21:04, another system records the exact same event at 23:04, and then your central dashboard logs it at 21:09, which of those timestamps is the absolute truth? Well, the unsettling answer is possibly all three of them. They might simply describe different moments in the data's life cycle, they might be using different time zones, or they could come from clocks that were just never synchronized to begin with. If you simply pick the timestamp that best fits your working theory, you're not objectively reconstructing an event. You are just selecting a narrative. Let's move into Section 1, the illusion of precision and the false comfort of machine time. When you see a timestamp stretching all the way down to the millisecond, it looks undeniably authoritative, right? A machine produced it, so we naturally tend to trust it implicitly. But this level of precision creates a false sense of comfort because it doesn't answer the absolute most important investigative question. What exact moment does this timestamp actually represent? A highly precise timestamp does not automatically tell you if it's marking the exact moment the activity occurred, or the moment the application noticed it, or when a logging agent actually created the record. It might just be the moment the central platform received it, or even when it was exported for your screen. Those different moments can be separated by seconds, minutes, or even hours. None of the systems are necessarily lying to you, they're just answering fundamentally different questions. Section 2. When recorders disagree and real-world forensic discrepancies. Let's look at a concrete example from a publicly documented 2025 rail safety investigation. The analysts needed to synchronize monitoring data with event recorder data, but they quickly realized they couldn't just apply one universal correction. Unit A required an offset of -2 minutes and 10 seconds. Meanwhile, Unit B, which was operating inside the exact same physical event, required an offset of +20 seconds. The underlying events were entirely real, but the raw timestamps, they were completely incompatible. The investigators had to mathematically reconcile those clocks before they could even begin to construct a timeline. The critical takeaway here is that two devices operating inside the very same event can wildly disagree about time, and they can do so in completely opposite directions. If those investigators had just blindly trusted the raw timestamps, the sequence of events would have looked materially different. And discrepancies don't automatically mean a system is broken or compromised. Sometimes perfectly functioning systems are just following different rules. Take leap sparing, for example. Systems like Google Public NTP use this process to gradually distribute a leap-second adjustment across a full 24-hour period. That avoids abrupt clock jumps. Compare that approach to a well-known 2017 incident where Cloudflare experienced a massive DNS service disruption. It all came down to a leap second. Their software essentially assumed time to never move backward, so when the clock behavior violated that assumption, the system calculated a negative duration and just failed. Cloudflare's analysis actually showed their production system failed because its model of time was simply too basic. So two properly functioning systems can represent time very differently during an adjustment period. Discrepancies absolutely do not mean fraud or manipulation by default. Section 3. The 4 clocks of evidence and the journey of an event. To make sense of all this, you have to realize that every single piece of evidence travels past 4 distinct clocks. First up, you have event time. This is when the originating device, say a laptop, a security camera, or an access controller, believes the activity actually occurred. Second is record creation time. This is the moment an application or an agent first generates the log entry. Third is ingestion time. This is when the record finally lands in your central repository or your SIEM. Network delays, outages, or routine batch processing can heavily separate ingestion time from event time. As just one example, AWS explicitly states that CloudTrail usually delivers events within about 5 minutes, but that timing is not guaranteed. Late arrival is absolutely not proof of late activity. And finally, the 4th clock is display or export time. This is when the interface actually converts UTC into your local time zone for viewing. These 4 clocks are related, for sure, but they are absolutely not interchangeable. Let's see how this actually plays out in a realistic composite scenario. Imagine an after-hours VPN connection. If you just look at the raw timestamps, it looks like a mess. The VPN says 21:04. The laptop says 23:04, and the SIEM logged it at 21:09. At first glance, you'd think the laptop is 2 hours ahead, the SIEM is 5 minutes late, and you basically have 3 conflicting events. But if you look closely at the normalized time, the picture changes. The laptop was actually operating in local time, UTC +2, When we normalize that back to UTC, the laptop event is 21:04:10. The VPN event is 21:04:12, so they only differ by 2 seconds. That remaining 5-minute gap to the seam, that simply reflects pipeline delivery delay. The conflict was entirely an illusion of presentation, not a difference in the physical activity. It was one single honest event. Section 4. The Reconciliation Protocol. How do we systematically normalize these digital clocks before we plot them on an investigative timeline? Before you build any timeline, you must apply these 6 steps. Step 1. Preserve the original value. This is absolutely crucial. Never replace the raw timestamp with your newly converted version. The original remains the evidence. Your conversion is just your analytical interpretation. Step 2. Classify the timestamp's role. Ask yourself, is this event occurrence, ingestion, or export? Step 3. Identify the time standard. Are we looking at UTC or local time? Does the platform use leap smearing? Step 4. Examine the clock source. Remember, a timestamp can never be more reliable than the actual clock that produced it. Step 5. Measure the pipeline delay. Compare the event time directly to the ingestion time so you can spot network congestion. And Step 6. Find an anchor event. You want to look for an independently observable action, like a physical door opening or a documented phone call, so you can reliably measure the offsets across your different systems. Section 5. Limits of forensic evidence in categorizing certainty. You see, true forensic precision isn't about just adding more decimal places to a number. It's about communicating exactly what your evidence can and cannot support. As investigators, we have to clearly distinguish between layers of certainty. First is the observable artifact. That's the raw log you export. Next is the authenticated technical fact. That is the anchored, normalized time that you've rigorously verified. Then we have analytical inference, which is your estimated pipeline delay. Below that is an unresolved hypothesis. That happens when you have unreliable absolute timing that just cannot be fixed. And finally, a legal determination, which is quite frankly not a timestamp at all. Patterns of disagreement in your timestamps, like a constant 1-hour difference that strongly points to a time zone issue, or a gradually increasing difference that points to clock drift, those are investigative leads. They are not automatic proof of guilt, intent, or manipulation. To highlight this, let's look at another public transportation investigation. This time it involved an onboard camera. Specialists examined the recovered video files and quickly realized the timestamps were completely wrong. They tried to calculate an offset using the camera's current clock, but the result they got was totally unreasonable. So what did they do? Well, they exercised good forensic discipline. They accepted what the evidence simply could not establish: reliable absolute clock time. Instead of trying to force bad timestamps into a neat timeline, they relied strictly on what the evidence could establish, which was file sequence and relative chronology based on sequential file names. Sometimes the correct forensic conclusion isn't a beautifully mathematically corrected timestamp. It's having the discipline to state that absolute time just could not be reliably determined. Section 6. The bottom line: reconstructing the truth. Let's bring all of this back to your direct responsibilities in corporate governance, compliance, and evidence analysis. When you start your next investigation, I want you to apply these 3 practical actions immediately to your workflow. First, preserve the raw timestamp, its format, and the recorded offset as completely untouched evidence. Second, consciously measure pipeline delays separately from event occurrence. Always acknowledge that a late arrival does not mean late activity. And third, find an independent, observable anchor event that appears across multiple systems. That is how you reliably measure offsets. Never assume that just because 2 labels match, the underlying systems were perfectly synchronized. Because when it comes down to it, the most crucial point is this: a timestamp is not a verdict. It is merely a value produced by a clock, a configuration, a software process, a data pipeline, or even just a display decision. Your job as an investigator is not to simply choose the timestamp that best supports a narrative. Your job is to meticulously reconstruct exactly how every single system produced its time. We'll leave you with this challenging thought. If a perfectly formatted, completely pristine timestamp can still place the truth in the wrong hour, is your timeline a validated chronology, or is it really just a hypothesis? A precise timestamp is not automatically a validated timeline. Normalize your clocks, preserve the originals, and always document the uncertainty. Semvanski Labs and Research, Forensics over Fiction.